In this tutorial, we're going to continue our math primer and review on the essential mathematics and algebra, as well as trigonometry for undergraduate physics. And today we're going to talk about a topic that many students struggle during the first couple of years of undergraduate physics, and not only. And this is vectors. So physical quantities that are called vectors are, for example, we can refer to the so-called velocity, and you most likely have heard me talking about using the word speed instead of velocity. I will explain what the difference is. So velocity is a vector quantity. In other words, we need to know how fast, which also known as AKA the speed, how fast something is moving, but also we need to know the direction that this object is following. For instance, the velocity of the wind. Right? Example: the wind has a velocity of 5 meters per second, and it's north-northeast. So we need to know the direction. The same is the force. So when we say push a box, we need to know the direction that we're pushing it. So the force is also a vector, and it's again denoted with a little arrow above the letter that we're using to introduce this physical variable. And of course, force, acceleration means force means acceleration. Newton's law of motion. Acceleration is also a vector, as opposed to scalars, which we discussed in the previous lectures, where, for instance, mass is a scalar because it suffices to say that my mass is, for instance, 5 kilograms. So we're going to discuss vectors primarily on a Cartesian set of coordinates. In other words, our usual x-y axes. This is my y, this is my x-axis, and let's define a preliminary vector that we're going to call, say, c. Vector c equals to, with no number, just parameterization, like a in the I direction and b in the j direction. Of course, we may have, for instance, a k direction, and a 3-dimensional vector. In this particular case, is a 2-dimensional vector. So what does this mean, right? It means that we're going to have these I and j's are called the unit vectors. These are the unit vectors I and j. And essentially, it tells us that we're going to have, if a unit vector has a magnitude of 1 along the x direction, a unit vector along the axis of y, unit vector j, has magnitude equal to 1, then my vector a times I is going to be a times I. So whatever this number is going to be 3 times, a times my I vector, and the same, of course, b times the j vector. Let me give you a numerical example, and I think that's going to be easier to understand. So let's take this vector to be, my vector c, say, is 2 in the I direction, and this is plus 3 in the j direction. And let's assume that this vector is, let's call it u. It's just to indicate that this is essentially the velocity of an object that is moving. U in the I plus 3 in the j, the units are meters per second. And how would we sketch this? We're going to sketch again a Cartesian coordinate system, or a typical x and y axes as we know them. So if we have this ix and this is as y, we're going to count 1, 2. We have 2 in the I, 2 i's, right? So 2 units along the x direction, and 1, 2, 3. 3 units of j along the y direction. So this is 3, this is 2, these 2 points are 2 and 3, and from the center of axis, we're going to draw an arrow where we're going to say that this is our vector u. This is our vector u. So, for instance, one question can be, well, okay, that is my velocity ui plus 3j. What is the speed? How fast is this thing going? Well, that's quite a different question. You guys, when I introduced the vectors, right, we said how fast. So for a vector, we need to know 2 things. Then what we call the magnitude, which how fast is the magnitude, and the direction. But how are we going to extract this information? So this is precisely what we're going to be talking about the next 2-3 minutes. The magnitude is shorthanded by the 2 double vertical lines, like something like the ABS, like the absolute value, but with a double line. That means that identifies the magnitude of my velocity, and it's essential the length of this vector. The length of this vector is essentially the magnitude of this vector. So in particular case, when we talk about velocities, the length of the velocity arrow represents nothing more than the magnitude of this vector, which is going to be called speed. And how do we find the magnitude of this vector? Simply using the Pythagorean theorem. This is the hypotenuse. So this is going to be 2 raised to the power of 2 plus 3 squared. And this makes 4 plus 9 square root of 13, which is approximately 3.6 meters per second. 3.6 meters per second. So this is the magnitude of my velocity. So here's the difference between when we use the term velocity and speed. So imagine that if my object is moving from left to right, or right to left, it doesn't matter. I know that I have one direction, so I'm not using the word velocity, I'm using the word speed because it is along one dimension. Now if you cannot call speed along 2 dimensions because you have a vector, like I just showed you. Now what else we need to find? We need to find the direction. So we found the magnitude, now we're going to find the direction. How